Hey everybody, welcome to Houdini Hangout. Hope you're all having a great day, night, whatever time it is for you. Nice to have you here. My name's Peter. Hope you're doing well. Sorry, started a little bit late today. Had a client meeting that ran a little over, so apologies there. But here we are. We're gonna get things rolling, regardless here. So today we are going to do a little bit of Copernicus stuff. That's the idea, at least. So we'll do that and see how things go. Certainly happy to have your suggestions and have your ideas as far as things that we should do for for this Copernicus, like looking into Copernicus stuff. Somebody suggested looking at some, some slap comp stuff. So we can certainly do that as well. But yeah, lots of things that we could look at and do. So if you have any thoughts or suggestions, I'm always happy to have those in the chat. Welcome everybody. Sorry, seeing procedural nodes and Enya and Zach and everybody. Nice to have you all here. K4, welcome. Nice to have you all in the chat, hanging out. So like I said, we're going to do some Copernicus stuff. Obviously, it's kind of hard to say that I'm an expert in any part of Houdini, but this is certainly one of the areas that I've been learning the most recently and like trying to like get into. So certainly I have a lot of ways to go in my knowledge on Copernicus. So be prepared. Might not be as smooth as normal. Oh, those dice. Oh shoot. We just put them away. Actually earlier today I had them on the desk next to me. I think they're called. I think my wife just yelled from the other room. Hold on a second. My wife's gonna grab them for me. Hey, hello. Let me see. I'll from stage right. I'll get them. There's story cubes. Oh yeah, there's also art dice too. These were a different thing. I did not use these. Art dice come in this cool little tube, and there's story cubes. There were 2 of those. Oh, is this? Oh, right. This is actually like more green, but because I have the green screen thing on, it's like it's taking out the green from it, so it's like sort of making it invisible, which is funny. But there you go. Everyone says hi, Catherine.
Hello.
So anyways, yes. So there you go. Story cubes. They're very cool. Lots of fun little icons on them as well. So it's a pretty cool thing if you're trying to do, if you're trying to do something creative and random and you're just like, hey, let's do something. Anyways. So yeah, there you go. But yeah, if anybody has any thoughts or suggestions about things that they would like for us to play around with in the in Copernicus, please drop them in the chat. It's certainly, like I said, not something that I'm like super deep into. Been learning a lot with it recently and trying to get better with it. But we'll try, see what we can get into, kind of regardless there. So that's what the plan is going to be for today. Like always, if you have thoughts, comments, questions, ways that I could be doing something better, want to Mrs. Hangout, that is funny. If you guys have anything that you would like to add to the conversation, I'm always happy to have that here. Want to yell at me to use a different node, or I can't remember the node name, better roll the dice. I guess I should roll the dice actually, I guess, for this, because I'm not 100% sure what we should do. But I think there's some things that we can get into. We can look at some of the different stuff within slap comp and see sort of how some of those things work. But yeah, maybe we'll just, yeah, maybe we'll start really basic. If you guys are all pretty new to Copernicus and that type of stuff, we can start really basic and go from there and see kind of what we can get into. But yeah, anyways, if you have something to drop in the chat, please do that. Happy to have that. If you'd like to join the Discord server, you can go to HoudiniHangout.com. You can get a link to the Discord server there. And yeah, there's people chatting on there. It seems like every night I wake up and there's some little chat that's happened on there. So all you Europeans, sorry that my sleep schedule doesn't line up well with your work schedule maybe, but yeah, everybody's been really nice and helpful on there, so it's been great. Hopefully if you've had any questions, they've been answered well, and if not, then sorry, we don't know everything, but cool. Oh, hey Mandy. Hey, I think Mandy, you were one of the winners from 3:51 a.m. Holy cow, that is late. One of those half-hour off ones too. Hi from Sweden, great. Mandy, I think you did stuff for for Houdini this year, I think, and it was really awesome. Nice work. I think you got some victories throughout those days, if I'm remembering the right person. Anyways, yeah, so let's do it. Let's jump over into Houdini and start messing around with some stuff. All right. So, yeah, so some people are talking about. That's awesome. Yeah. Well, I was actually one of the judges for Houdini this year, which was really fun to do. It was kind of crazy because I was actually out of town for like half the month, it seemed like, or for at least a couple of weeks. So doing that like while I was traveling was maybe a little too much. I shouldn't maybe have done that, but it was really cool because Houdini was kind of where I first maybe even got the idea for being able to do this stream. So just like, oh, I could probably do this live. Like I have to do it crazy fast, so I could do it live. But anyways, yeah, congrats on 3rd place. I think that was similar to what I did the one Houdini year that I was a part. I like did every day. I think I got a 3rd place. I don't know. I got a hat or something. I think I got the hat that I've worn on the stream a few times from it. But anyways, yeah. So some folks are talking about what compositing, what COPs are. Copernicus. Copernicus is just a term for COPs, right? So it's compositing operators. It's a whole bunch of different 2D kind of things, right? But yeah, so there's all sorts of different things that you can do. You can do some live video stuff. Yeah, there's lots of different things that you can do in there. Somebody was asking about noises. In COPs, yeah, we can definitely take a look at that. Yeah, there's simulation in there that works, which is really neat. Lots of different things. So it's a very versatile kind of 2D compositing workspace, but it's not even totally true that it's 2D, right? So we can talk about that a little bit. That's an interesting question. So I just got a question that says, how can I change the default Houdini to match my layout? So first of all, I am in a yeah, Copernicus. What am I typing here? Copernicus. Apparently I can type. I don't know. We'll say slam comp. Maybe that's what will work. Maybe we'll just say Copernicus basics. Something like that. So here's how you can change your default layout. So I made a version here. But yeah, so like if you were in, let's just go to build, for example, here. So this is what it looks like default, right? And so what I usually do to kind of go over from this is like, well, first of all, I'm just going to get rid of these because we don't need all of these guys here. Just kind of remove those. This geometry spreadsheet, what I do first is I click on this little arrow. I do split pane top bottom, and that'll split me out a geometry spreadsheet down there, and I can close that. So now I have my geometry spreadsheet down here. And then I can move this over a little bit. So you can grab this middle part and move it like that. And if you alt click on these little dots in between here, it's actually going to snap it top and bottom. And then I just switch them like this. So that's kind of my default setup. I mean, it's slightly different, but if I go to objects, there we go. You can see here, this is pretty much what my setup looks like. It's maybe a little different like proportions, but that's more or less how to do it. And you can do this with a whole bunch of different things. I mean, another thing you can do as well is you can actually have like, you can have like if you had these two, right? If I split this top and bottom like this, a lot of people will do this where they'll have multiple networks and multiple parameters. And then you just right click on these and you can say, this is going to be 2 and this is going to be 2. And then these will live together. And so here I could go to lops, for example, and these two go to lops. And then up here, I could say this is 1 and 1. And then maybe I don't know, maybe this is 1 as well. And this is, this will link to whatever the last selected one is. But then up here, I could change this probably over to object. And so now you can see that you can have like separate fields together, right? So you could have these two things going together, and then this could be your scene import or something like that, right? And then you can start putting these things together. And that's, these are all things that you can kind of do. Lots of different things you're able to do here. Interesting. This one actually didn't. Not sure why that one jumped that way. Thought this one should stay the same. But anyways, you can do this kind of thing. And yeah, it's pretty handy. Anyways, I am going to delete that. Oh, actually, I want to keep that. Let me just go back to my standard view here. There we go. And then if you ever need to like reload it, you can do that. That'll reload your current thing. Cool. Yeah. And then we're going to be talking about slap comp a little bit too, which allows you to actually take in like AOVs and things like that you're, AOVs that are coming from renders, and you can actually use that and then composite it back on top right in the viewport. But we'll get into that in a second. That'll be something a little bit more. So this is actually something I just realized. You can put down a cop network here. But I was reading some internal conversations, and it looks like it's actually a better idea to not have it there, but put it into here, into a cop network in here. I think the reason being that this is actually a more easy, like this is actually where the geometry is being created, right? Like you're actually creating like an output here. So for example, if I just came in here and made like a constant or something like that, just something that's a color, right? And we made this, I don't even know. That's black and white. So we need to go to RGB. There we go. And let's just make some like a color here. So if I come back up, this is still in the viewport, right? So I still have this color in the viewport. So some insider information. Yeah, I don't remember the exact technical reasoning behind it, but they were like, oh, this is a much better way of doing it. And I was like, oh, okay, I've not been doing that. That's interesting. So anyways, just something for what it's worth. But anyways, this is, this is what they were mentioning is kind of the way to make this easier here. Zach's asking a question. Say I created a CopNet at the object level and did a bunch of work in it. Is there an easy way to move it inside the geo context? Yeah, you should be able to. I mean, it's not really a problem. I wouldn't say like doing a cop network here like isn't going to be the end of the world. It's just a little bit different, right? Because like it's just in a, you have this like kind of place where you can start adding nodes to it. Otherwise in here, you can't like get at this and like work with this very easily, right? Like if you wanted to manipulate this over here, like I think you can even just like, you could just put a transform down and like just start messing with it. Like not that you would, but like it's just, this is a Houdini thing, right? It's Houdini geometry already. It's just a layer. It's a volume basically. So anyways, that's why they're saying I think it's a little bit of a better idea to work that way. You can just do what I did though, Zach. You can copy and paste. Like you could just, as long as you're inside of the cop network here, you could copy this, go up, come inside of this cop network and paste it there. Those nodes will paste. Whenever you're copy and pasting things, you always have to remember that you can't copy and paste to different contexts, right? So as long as you're copy and pasting to the same context, you'll be totally fine. The other thing you can do as well though, is if you don't want to do that, what you could do here is, let's just say, I'm going to make this one a different color just so we know, make that one red. So let's say you wanted to go into this, wanted to look at this cop network here. You could actually use an external cop. You could point to this cop net, I believe. And yeah, there you go. Now we've got the red output there. Yeah, Kieran, he's a good dude. Appreciate your help in the Discord server. Always very nice to see you in there. But yeah, this way you can actually link between Cop network. So you wouldn't have to move that all if you've done that already. It's just an extra step that you don't have to do if you create it this way. So, it's not like it's going to be like a problem or anything like that. It's just something I noticed and I was like, oh, this is cool. But yeah, there's always more than one way to do everything in Houdini. So get a nice error going there. Let's turn this off here. Great. All right. So let's go into Copernicus and start playing around with some stuff. Let me also, before I do that, it's going to be Copernicus basics. Let's do a geometry node here and let's just throw something in here that might be kind of fun to play around with. Let's see. I'm going to use the Cappy. I just like him. He's nice and simple. Let's do a oh, actually, sorry. What I should be doing is doing this in Solaris because that's where I'll actually be doing the slap comp. So let's do that. So I will just do a LOP network here and we'll just call this Solaris. And in here, I'm going to do a SOP create. And this will just be called Cappy. And I'm going to make this add world geometry OS. So now we should have that going. And in here, I am just going to do a Cappy and have him animating. Cool. All right. So let's do a joint deform on this. Do an output as well. There we go. So now we have our walking capybara. Great. Cool. We'll go up a level here. Something actually I kind of realized recently was that if you use a SOP create to do this, you can actually autofill your materials in here, which is kind of nice. So you'll actually get some materials that'll come in. So might be a nice thing to have. Also, let's see here. Can apply the normal map to this. I forgot that that's a thing. So let me just autofill those again. There we go. Okay. So we have our capybara. Let's see. What should we do with this? Let's try some stuff here. Let's give a grid for the ground, maybe. I don't know. I'm just kind of coming up with some thoughts on the fly here. Just call this ground. And again, I'm going to just copy and paste this over to here. So now we got world geometry, we got ground, we got Cappy. Great. Is there an advantage to doing a LOP network under object versus going to the stage? Nope. I just like that I can do this. I like that I can go up and get into my LOP network here versus and then go into Copernicus. Now, the other thing I could do is in here, I could do a Cop network, right? So, I mean, there's always more than one way to do everything, right? I mean, so yeah, for what it's worth. So let's do this and let's see here. Let me grab a camera. Actually, I'll do it over here so that I get it at the view that we're at here. Let's just move this around a little bit. Okay, so there's our camera. And I'm actually going to put this, I'm going to say /world /cameras / I'm going to do a rotation null. So I can actually add a null in here this way too. So under cameras, I now have a rotation null. So the reason I'm doing that is I want to do a transform here. Sorry, we're doing a little Solaris stuff here, but that's okay. It's all intermixed. We'll do this and then we'll do our rotate. We'll do $F -1 because I want it to be starting at 0. The first frame is 1. And then we'll multiply that times, gosh, I don't know, 10, maybe 10 degrees a frame. Is that too fast? I don't know. Yeah, it's probably too fast. Let's see here. Yes, it's way too fast. Let's do 5. Let's cut it in half. So this is basically just rotating it by 5 frames. Maybe we can add some pink and glitter. Cool. So yeah, so here is our capybara, right? Walking around. We've got a camera moving around him. The reason I want to do that is because Copernicus is actually very camera aware. The other thing I'm going to do is sample frame range here because I want to make sure that we're getting all of our frame samples written. Another thing I am going to do is I'm actually going to do a cache node up here because this is going to make this whole thing a lot more performant, because right now we have a time dependency here and I just want to take that time dependency away. So let's see, Plankton asked a question about, is there any relevance to the object level? So the object level is just something that's existed for a really, really long time. And that's where all of the old lighting, rendering, all that kind of stuff was kind of contained around. Now that we have Solaris, it's a little different, right? Because we're able to, now that we're able to kind of set up these scenes in USD with Solaris, it's a little bit of a different way of working, and it gives us the ability to make scene descriptions like live as we're working. So it's just a little bit of a different way of starting off. And, you know, I don't know. People have asked me, oh, is everything going to be done in LOPS in the future? I don't know the answers to those questions, obviously. I think certainly if we can make the Solaris space a place where people want to be working all the time, then I don't see why it would be a problem, because it really serves the same function as OBJ. There are some of the USD things on top of it that are tricky, but the more that we can kind of make those feel seamless for the user, that could be a possibility, I guess, in the distant future. I don't know, but yeah, it's kind of just a thing that everything used to be an object, and now Solaris is an option, and you can do a lot. You can just do SOPs. You can nest your networks kind of in any way. So that's the tricky part, is you can work either direction. So yeah, there's not like one right or wrong way. There are just some caveats in Solaris, like what I just putting down that cache node. Like in SOPs here, if we hit play and just watch this, it's super fast. And in fact, if I let it go, it's insanely fast. But USD is just a different beast, right? And it wants files on disk. So it gets a little upset when things are time dependent. So this cache here is going to be a lot faster, right? Because now everything is cached and it's on the stage. So now he's going to be able to move around a lot more quickly. Same thing with this transform. We've written all of the frames now out. So now if we hit play here, this is going to be way more smooth. In fact, it's going to be too fast, so I can slow it back down. And now we can actually see that that's still too fast. So I'm going to bring this down to like maybe 2.5, something like that. We can get a nice moving capybara. There we go. All right, let's put some lights in here as well, just so that when we have a render, it's going to look kind of nice. Let's do a Karma physical sky, maybe. And let's do this to 1. And let's just maybe, I'm just going to turn on Karma CPU here for a second, just to see what we're dealing with. I'm going to turn off the grid. You can also turn off the lights here. Let's keep it through the camera. Yeah, let's do it like something like that. We'll do it like 135. Cool. Yeah, so the reason that the time dependencies are slow for something like SOP create is because it's translating that information every single frame. And it has to then rebuild a whole bunch of this scene graph down here every frame. And so that's the slowness. When you throw this cache in here, now we've actually brought all of those time samples onto our stage. And that's actually visible right, sorry, here, if I go to skin, and this is like the, kind of like your geometry spreadsheet in SOPs. And so if I go here and look at like points, for example, which is the positions, you can see I have 240 time samples here. So it knows all of the point positions for every time sample, and it has it all available like in memory on the stage now. Normally it would want that in a file. That's like the best scenario for USD, to have all that information in a file that it can readily just read back at any moment. But a cache is like an in-memory way of doing that. You wouldn't want to do this on like huge things if you're doing something gigantic, write it to disk. But in this case, it's not a really big deal. No, this cache is not written to disk. This is completely just in memory. It is not an an on disk thing. If you wanted to do a file cache, you can do the same thing here that you would do, obviously, like at a that you would do in the SOPs world. But this is going to save it to USD and make a USD file for you. So Yeah, it's kind of like a stash, except it's not saving into the file like a stash does. It's kind of like that. Yeah. There is actually, I think there is a cache at the SOPS level as well that would cache all the stuff into memory, but it so rarely is needed to be used, I feel like, these days. But yeah, so it's similar in some ways to a stash, but it, like I said, it doesn't up the size of your HIP file like a stash would. So yeah, anyways, cool. So this file cache would be if you wanted to drop it to disk, and that's a totally valid thing to do, especially if you've got like a file that you're pretty happy with and you want to save it out to disk and, you know, put that into all your workflow stuff. You can do that. I'm going to turn this off for now. Okay, cool. So we've got all this stuff. We've got our physical sky. Let's just do our karma node here. So this is going to go down here. The karma node puts down two things. It also brings up that little message about saving out your render kernels. Is that what they're called? Yeah, I think they're called render kernels. Anyways, my brain's blanking right now. But yeah, RAM. The cache node works off RAM, not the VRAM. The VRAM would be is like Copernicus. Copernicus is all GPU based, so that'll be 100% your VRAM. So Karma render settings are here. I'm just going to set up the camera to make sure that's what that little error was for. And now we're good to go. We've got our CPU here. We could maybe do XPU. Doesn't really matter right now, but we'll just leave that be. So we've got a whole scene set up here that we can use to play around with some stuff. We've got our capybara and we've got our camera here. And so, yeah, so this will be like our, throw this on, could look through this and do this, and we can turn off these things. And then there you go. Yeah, so each frame here, obviously we're going to get a different angle of him as we zip around him here. We should have motion blur. That's another nice thing that this cache does, is it makes sure that you've got all those things written to the stage, which allows you to make sure you have motion blur. Yeah, exactly. Kieran's 100% right. Don't use the cache node if it's a huge thing. If it's like a simulation or something like that, you're gonna be losing your mind. I mean, it was quick for me because this is just a character walking, right? It's not tons of data. Yeah, it'll need to cache every time. This is just something I'm doing just to kind of quick and dirty make it work and do the stuff that we want it to do. But yes, Kieran's 100% right. Don't use this for like your full workflows. Not a good idea. But yes, anyways. Or if you want to make sure that all of your, like if you're making an asset or something like that that's animated, you want to make sure all your time samples are available, throwing the cache down would make sense. You could do that as well. If you have like an animated asset, not one that maybe you want to have a bunch of different assets on, but something that always has the same animation for some reason, you could do that and cache the animation into your asset itself. But anyways, this isn't a USD thing. Let's play around with some Copernicus here. So we've got all this stuff set up. And what we can do here is we can go into Copernicus. Actually, you know what? Probably makes more sense to not have this over here, so I have to jump up 2 levels every time. So let's just put Copernicus over into here for now. And I'm going to do a comp network over here. And I'm just going to call this slap comp. There we go. Okay. So what we can do is we can actually do a slap comp block. And this is nice because it's a little recipe. It's going to throw down everything that we kind of need for this, right? You can also see here that this is automatically grabbing our slap comp import node. And this is going to grab our file from disk here, right? And so this is obviously super helpful. It's bringing in this the color and depth information from our scene already here. If we want to change this, we can go to depth and we can see that information as well. You can just change them right there. You can also have, let's see here. We could also have a viewer, which would be, you could use the composite viewer. This would be a little bit just like a 2D viewer that you can use. Slightly different, gives you some extra features and you can't tumble around in it like this one. But I think an interesting thing that you start to realize with this is that this is actually a piece of geometry, right? And it's kind of 3-dimensional. So this is what you would do for a slap comp. But if we wanted to just get the actual geometry here, what we could do is Let's see here. Let's do something a little bit different here first, because this is the render and we can grab this and all that kind of stuff. But we can also do, let's see, we could do a, oh, right. See, this is where we get into a little bit of a different world here, because that's right, there is only a SOP import here. Wait a second, sorry. But I should be able to bring this in. Sorry, I'm just trying to remember all my stuff. Yep, okay. So I can bring in this camera import, right? And hey, Tom, how's it going? What we can do then is, what we should be able to do is bring in these and have them animate around. Now, unfortunately, no, actually, sorry. What is this doing? I think I'm getting myself mixed up here. Sorry. Because I think like this is fine for doing slap comp stuff, right? Because we've got to go from Solaris to get the slap comp actually working. And as long as this is cooking here, we should be able to make this work, I think. Let's see here. Oh, there we go. Okay. That's how we do it. Sorry, I missed that little checkbox there. Right. So this is going to, what this is doing, right, is it's actually going to be running when you use this little slap comp button right here. And so we can click on this, and now we're actually running it through that slap comp block. And if we did something like a blur here, we should see this update. So let me see. If I go to that, there we go. And there we go. So now we can actually see in our viewport that we're blurring this, right? So if I move my network around, this is all blurring, right, from Copernicus. So we're able to do a whole bunch of different things with this. So this is actually why you would do that kind of a workflow in Copernicus. But now that I'm thinking about it, everything is coming from SOP geometry, right? And so yes, it does match my camera already. You're 100% right. So the other point that you would do this with would be just if we wanted to do the basics of it. So let's take a step back here and take a look. So we will actually make a geometry node here. Say Copernicus basics, cop network here. And I'm going to do the same thing I did, but just with the capybara at this level. And what we could do is we could do a camera. Actually, sorry. Let's see here. So let's do cappy. We'll just do the exact same thing we did there. We'll do a join deform. Throw that on there. And then we'll do a null. Just call this cappy walk. Great. So now we've got our capybara walking. And so what we're going to do is we're going to say Copernicus basics. Cool. And I'm going to throw a camera in here as well. So we'll just have another object level camera that we can work with. So I'm just going to throw this like so. We'll do a camera. So this is now an object level camera. Someone was asking about OBJ. And so now these are being written at the object level. This Solaris stuff is all kind of contained within there. So here's our camera. Let's add a null here. And then I can just transform this doing the exact same thing. So I can do $F -1, which is the current frame -1. And then I can do this times 2.5 degrees. Did I mess up here? Did I? Oh, I wrote the wrong way. There we go. So now that should do very similar thing. Great. Yeah, thank you. Oh, silly. Okay, so let's see here. So I just want to make sure that this is going around properly. Cool. Okay, we've got Cappy walking around there. So now we've got that. We can come back over here. And so the cool thing about this is that we can bring in renders, but we can also bring in geometry. And so now we can do this SOP import if we want to. You can also create SOP geometry right here. So you could do SOP geo. I mean, both of these are the same thing. You could actually, there's actually a SOP network inside of here. But again, we're doing nested craziness. So we'll just do this. So now we can grab Cappy walk here. We've got geometry coming in. And what we can do is we can also bring in a camera import. This is actually going to import the camera properly. So we can go here and grab camera 1. So now this should actually grab that camera in the appropriate way. It should hopefully be moving around. It sure is. Look at that, because it's knowing how to figure all that stuff out. Great. So we've got camera import here. It's bringing in the camera, and you can see that there is a kind of a window following it. And that window is going to be the kind of the key to understanding what some of the cool things you can do with Copernicus, because we actually know the direction of this camera, right? So what we're going to do is just rasterize this real quick. So we could rasterize geometry, and we'll throw in the geometry here. We'll throw in the camera ref. And then if we look at this here, we can see that we have our intrinsic alpha that's being referenced, right? And so we can see here that as, like, if we look at it from the camera's perspective, we can see it moving like this, and he's, you know, rotating around and doing all that stuff. But it's a little strange, right? Because we have this camera position, right? So what you can do is you can do a match camera, I think, and we can just do this. If we have this blank, it will actually put it back into this sort of canonical world space, right? Kind of right in the home of kind of the scene. And now you can see how this is actually working. I'm just going to go back up here real quick. Sorry. Turn off this null just so we don't have to see it in there. But so you can see here now we have this kind of laying at the home position, basically. And any attribute that's on this geometry could get rasterized, right? So right now we're just rasterizing the alpha. We could do any sort of thing. We could do the position, could do the normal. Maybe this doesn't even have a normal, sorry. If it doesn't, I will add normals to it. And then I'll also add just do an attribute adjust color real quick here and do something fun with it. And just say, let's just do like a noise. And let's see. There we go. There he is with his noise color craziness. And so we should be able to come in here and we should be able to add that. We should be able to add CD. And now what we can do here is we can take this rasterized geo. I'm going to put this, set the viewport to front. There we go. So we can just use that. And now I should be able to change these to position. So this is going to be, oh, that's weird. Got a warning there? Why did I get a warning? Oh, right. Because this is only the alpha, intrinsic alpha coming in. That's right. So I have this directly connected to this. And that's why we're actually seeing that. There is actually a better way of doing that. We can take a look at that in a second. But so let's look at this here. This one's already moving around. So I'm just going to look at this up in this perspective. So you can see here, obviously you can run into some weirdness with these being in different positions and things like that. So I'm just going to look through the camera for this for right now. We can see the positions. They're all being written there. Great. We can also see the normals, and then we could see the color attributes as well. So that is the colors that this has on it in its kind of CD attributes. So you can see it's now loading all those in. So this is a nice way to be able to kind of, you can bring in all sorts of different attributes into your 2D world and start messing around and playing around with these. This is also going to take into account the camera resolution, right? And so if I was to come up to the camera here and change it to the view to be something like, well, just let's make something more drastic. Let's do like 1024 square. And we go into Copernicus, we'll see that this is now 1024 square, right? So this will actually drive your resolution here. You can see 1024 by 1024. So yeah, that's what it's actually that's what we're working with here. We're actually using the camera's information to set that window size, to set that kind of space that you're working in, right? And so set this back to 720. That should be fine. So we've got some things happening here. Hopefully this is making sense. I'm actually going to reduce this and just hit P to open up this little window here, just to give us a little more room because we're going left to right here. So what we can do here is we can come to this match camera, and we should actually be able to do, maybe this would work. Oh, maybe not. Hold on. No, it doesn't look like that will work. I was thinking, so what you can do on some of these things is you can add an input port, and it'll use this little cable right here that'll give you all outputs, and it'll actually operate over all of them. But in this case, it doesn't look like that's going to work with this specific node. This node might not be set up to work with that. Anyways, what we can do, I'll go over to the composite view here, and we can see there's our node. And if we hit play here, we'll see it all kind of moving around. Looking good. We've got that all set up. So here we have, we're able to kind of bring these things in and rasterize them down into these flat 2D geometries, right? So you can imagine lots of different scenarios where this would be super, super useful. In fact, what might even be a better thing for us to do here, since we've got this going on, would be to go back over to our Solaris scene, and instead of having this be a SOP create, go to scene view here. I'm going to do a SOP import. Now this won't actually bring in our materials, but that's okay. We can make our own material for this. And I'm going to just make sure that this points to that Cappy walk. Cache that real quick. This will basically be the exact same thing, except he will just have color on him instead of having his actual skin. But now if we're referencing this in our slap comp as well, we're kind of working off the same geometry. We can't really reference this SOP import in, or this one in, as easily. We'd have to be kind of jumping in and out. Now you could reference it from this point, but I think it's easier to just have it all coming from the same kind of place. Like this is coming in from our geometry, and we'll just get rid of this one for right now. That's fine. And I'm going to call this one Cappy, and let me just make sure that I'm setting that up right. Oh yeah, it's just recaching quick. Okay, world Cappy. Yep. So let's set this up properly here. So I can just copy and paste this to put it in the right hierarchy. That should be good. Now you can see every change that I'm making here is actually going, needing to get recached through that. So that is something to keep in mind with this cache, is that it will slow you down. So if you're like doing a bunch of different stuff and setting it up, you don't have to have that on from the start, because it will have to it'll keep recaching as you're changing things on your stage. So it's really more for like once you want to start playing around and seeing the animation playback more real time, that type of stuff. Like for the end result, it doesn't do anything better for you. It just makes this playback a lot smoother in Copernicus itself. So yeah, there is our geometry moving around. So the input path prefix is something in Solaris, and what it's doing is it's just setting up this hierarchy down here. Actually, can I do this? Let me see. Yeah, I can. Cool. So it's just setting up this hierarchy right here for us. And so it's putting this world geometry in front of Cappy, right? That was the main kind of source of what we were doing there. So if I zoom back out here, you can see world geometry. OS is just the name of the node. So that's Cappy. So that's why we're seeing world geometry Cappy like that. And so that's the hierarchy that you're setting up. And that's just important for like, just think of if you're working in this geometry spreadsheet, you should just think of as like, if you're working in like any like outliner in Maya or like any object manager in like Blender or C4D or something like that. It's the same thing where you want to be really structured with it. You want to be really organized. It helps a lot with things down the road. And USD has a lot of really special mechanisms that allow you to use some of that hierarchy to your advantage. So we're not going to get into all that, but that's what that's doing. It's basically just setting it up in a better organization. So for me in this, I've gotten hierarchy decimated when I try to go back into Maya in the past. Yeah, I could see that. Now, the nice thing with this setup is that when if you exported a USD file and went back into Maya, it should respect all that hierarchy because it is, again, trying to be something that's supported in a lot of different places. So your hierarchy should remain the same between Solaris and Maya. I've definitely had that problem as well, where I've been working in Houdini and moved over to C4D or something like that for our final render when I was working in a studio. And yeah, sometimes you'd export something and be like, why is that not in the right path? Like, what's going on here? And it probably was just an attribute that was doing something goofy in an export. And then, you know, your hierarchy gets all out of sorts. Ibo, is there a way to transfer result from cop to be an attribute on geometry through its UV? Is there a way to transfer the result from cop to be an attribute on geometry through its UV? I think there is. I'm not 100. I know how to get the textures back onto geometry. Maybe it would be a geometry from map. Yeah, like attribute from map. I think that would work. Yeah, I think that would work. I'm not 100% sure, but that seems like that should work. Let me see if we can't. All right, so this slap comp stuff we'll get back to in a second. We'll go back over here and play with that for a second here. This is a little bit more in this realm of stuff. So the other thing that you can do, so this is rasterizing it from a camera perspective. The other thing, oops, I don't actually need to re-import this. We can also rasterize, we can do rasterize setup. And what this does is this is actually going to mess with our geometry. Now, this is something really interesting. There's actually geometry in Copernicus. Like, you can bring your SOP geometry into Copernicus, right? And so it knows that this is what it is. Like, there it is. And so we can actually mess around with this geometry before we rasterize it. So what we can do here, right now, this is just set to position. And we could move the orientation, do a bunch of other stuff as well. You can do fitting, stuff like that, right? But what we can also do is we can go to UVs. And this is actually going to break this all apart in UVs. Now, I've done some of this stuff in the past on here, and it's, you know, again, this is a big learning process for me as well. But what we could do here now is we can do rasterize geometry from this. We won't throw a camera into there, but we'll just rasterize this geometry as it is. Let's see if we can, actually, you know what? I could just pull this over since it's basically the same, and we'll just use those same attributes. So I'll just toss this in here. And now we should see that these colors are all done like that. And yeah, let's just do something from here. We've got a bunch of different things here. Maybe we can grab the color information and do, let's look at the noise. There's a bunch of different noise things in here. I think this phaser noise is kind of cool. So what we can do is we could throw in this, this phaser noise, and by default, it's going to be using the UV positions. So if we took this phaser noise, which is like a crazy looking thing like this, could kind of just play around with this and see if we can make the element size maybe a little bit bigger, and I don't know, something like that. Sure, we made a little thing. What we could do is we could just do maybe a multiply on these here and just multiply the color by the noise, and now we've got these like crazy stripes on it, like so. Yeah, let's do that. And then let's do a null here. we should be able to see, like this is now in UV space, right? So this is like a UV texture, right? So this texture could get laid back on top of the geometry as an attribute. So let's do this. We're going to say this is going to be our color. We'll just actually, sorry, I'll do out color like that. So that's our null. And then let's see if we can do an attribute from map. And now obviously this has to go after this Cappy walk because we can't have it be in the same position. But this is going to go into, right now it's going into our color. I'm just going to make this a little bit bigger here. This is going to be a vector. Yep. And the texture, I believe we should be able to do this. We can do this op syntax, and we can go to, this is in obj slash Copernicus basics slash, let's see what this will be. Oh, I called it Copernicus basics again, didn't I? Yep. And then let's do out color. Yep. And there we go. Now we actually have that attribute coming in. We don't have to have it be on CD. We could have it be on my attrib like that. And now we have a my attribute file along with our CD. In fact, I think if we put a null down, we won't see that very well, maybe. That's weird. Why is that showing up on top of the color? Is that being visualized maybe? Actually not sure why that's showing. Oh, interesting. You could grab a bunch of things from this. Anyways, my attribute is here, and you can see that we have a bunch of different values on here and stuff like that. And it's sticking right to it like that. So our stuff all sticks. So this kind of syntax is how you would get something from Copernicus live into something else. You just use this op and then the path to whatever it is. And you can see it actually fills it in for you, which is kind of nice. You don't have to actually be messing around with that too much. So hello there, welcome to the stream. Okay, so we have that, maybe some of those basics that we're understanding how they're working here. So yeah, if you guys have any questions about how some of this stuff works, happy to help out and you know, we can chat about whatever here. So yeah, you're very welcome. Yeah, hopefully that answered your question. But yes, let's think here. Is there anything else? Oh yeah, the cable thing that I was mentioning. Like for example here, we can actually just build a cable too. You can use this that would have all outputs, right? But say you wanted to work on a cable differently, you could do that as well. So let's look at what exactly cables can be used for. So let's do a cable pack, right? We can put this. Are we going to see painting tools and cops? Wouldn't you like to know? I don't know, man. Who knows? Who knows? I cannot talk about anything of that nature, and you should all know that by now. Okay, so this cable pack here is going to be useful because we can basically put these all into one wire. Now, this wire here would actually contain all of them as well, but in this case, I don't want to have the alpha in there. I only want to have these specific colors here. These color channels, basically. You can see here, these are RGBs. And so now this cable is going to hold all of those. I can set these from the input. So now I've got position, normal, and CD, our color. And so from there, what we can do, pull this down. What we can do from there is we have this cable with all of them. And let's say we wanted to do something I don't know. Like, let's say we wanted to set these all. We wanted these all to have the. Actually, I wonder if we can do this. Have the phaser noise applied to all of those. I don't know if that's actually even possible. Let's see here. Let's just do this. I have a feeling we can, but maybe this will prove me wrong. It's like we wired this in. Yep, that seems to be working. Okay. And so while that might not seem like too much happened, what it actually did is it applied this phaser noise to every single one of those inputs that are here in this cable. And then if we do a cable unpack here, okay, that's weird. We do a cable unpack here and we look at like the normals, for example, there's our normal values with the phaser noise applied to it, right? And so, oh, hey, Philip, welcome. Nice to see you all here. So this cable process here where we have the cable, you can kind of see it with this like glowy kind of wire here. We have this cable and it actually kind of works almost like a for each loop where it's looping over each of those things, which can be really, really useful. So it's just something to keep in mind here that you can do some of these operations kind of in a procedural manner like that. And that's one of the nice things with these. The nice thing with the stuff that was added in 21. The whole gang's here. Yeah, lots of people here. Nice to see everybody. So yeah, anyways, we've got a bunch of Copernicus stuff here that is kind of the, the basics of this. And like, yeah, it's a really nice little feature and it makes things really work really nicely, especially if you're doing something like say you're doing something that's a little bit more like almost like I would say like motion graphics-y. So like what you can do in here, which is really nice, is there's all these SDF shapes, which you can use. So like so these are really interesting. SDF shapes are these are actually like a visualization of how an SDF works, like in a 3-dimensional volume. Texture looks like a pillow I got from Walmart. But so what we can do here is we can do a bunch of different things. Like, so this is just a circle, right? But this white line is where we're it's basically like the surface you would see in an SDF, right? And so this is showing the outside of the SDF in blue and the inside in this yellow. And so, well, yes, please. Oh my gosh. Yeah, get some sleep. Don't have to stick around with me all night, but that's very nice for you to be up at a crazy hour. Appreciate it. Does it go down at all? That's true. Up north, it's a long time. So let's do a circle. Let's do a few of these here. Let's do a circle. Let's grab do we have an arrow in here? I think that's in like here, maybe. Yeah, I could do like a chevron. Cool. We could do a, let's do a compound one. We have like an arrow. There we go. Yep. We're just going to grab a few different things here. Make these a little bit. Okay, so we've got a circle, a chevron, and an arrow. And so what you can do then is we can do. So in order to do this, we need to do an SDF to mono, maybe. I mean, you could also do it to color or something, but this will make it into now a black and white. Basically just a float value, black and white image. But obviously doing this for all of these and having all these settings can be really annoying. So what you can do then is you can do a cable pack. We can wire all of these into. What? What did I just, there's an unreproducible bug for sure. I have no idea what that was. I still don't understand what Copernicus is good for. Okay, well we'll get there in a little bit here. I'm just showing a few things, and then we'll get into that. Okay, so really the main thing Copernicus is used for is like texture synthesis. So like create like substance designer basically, in that sense. it's not one-to-one with it. Obviously, we've got a lot of time to try to catch up to that. But anyways, so we do this cable pack. We can do an SDF to mono, and then we'll wire this in, and this will actually turn all of those into a mono, and we can, do it that way. We could also do an SDF to color and change that. Maybe that's actually more interesting. No. We'll just do SDF to mono. Great. So now all these shapes are mono, and they're all in this cable. And we could also change like the actual offset, the ISO offset, just like you would with a regular SDF. And then what we could do is we could do I think it's scatter shapes is the thing. Yeah, I think this is it. Yep. So what we can do is we can throw the stamps in here, and now we've got these all set up, right? And these are all our shapes in here. And so we can do all sorts of different stuff with this, right? So we have all these shapes here, right? And we can do jitter with them, right? And we can do all these things, but these can also be driven by noise, right? So we could do noise here. We could do like a bunch of different like fractal noises, right? And so you could throw this in here, and we could say UV. We could throw this into jitter, and this should now jitter around our shapes and things like that. And so what we can do is we can do this, and we could do 3D noise and animate. We should be able to do that. And we could do like, like this, right? So we can have these like, so now we're basically building like animated textures with this stuff. And we could also do, so yeah, we can do a bunch of different stuff here with this. So we could do another fractal noise, and we could throw this into, let's just say the angle, right? Sorry, it just has to calculate that there. And now with this, we're going to have randomized angles based on this, and we can up the contrast of this a little bit, and maybe just, we don't even need to probably, we could do 3D noise for that, animate it, maybe make the pulse length 10, something like, no, that's too much. Let's do 6. Okay, so here we go. We're starting to build these things, and we can see that we can now have these, shapes do all sorts of different crazy stuff, right? With these, and we could have different things with, the colors and all sorts of different things. So there's a lot of different random stuff that we can do with these, yeah, there's lots of really fun things that we can do. And since these are all packed together in this little cable, we wire this into the stamps, and it pulls from all of those. And we can do the stamp selection with a cycle. So it could do 1, 2, 3, 1, 2, 3, 1, 2, 3. I can do random. You can also use a layer to select the stamps. So there's lots of different ways that we could do it. Let me just see here. Yeah, so you could do random from ramp. There's all sorts of different things here that you could do. Anyways, this is some of like the more motion graphics-y kind of things that you could do with this, and have an animated texture that you'd build right within, right within Copernicus, and then use it in a render or wherever, right? So what we could do from this is I could actually, let's see, here's our result. I'm just going to do this as an RGB signature instead of RGBA, right? And I'm going to hit do null, and we're going to output this, and we're going to say out graph texture, something like that. And what we can do is we could actually come back over here, right, into Solaris, and what we could add to this is a material to the ground, for example, right? Why not? So let's do this. We can do a quick surface material, just a really simple material. We'll throw this, I don't know, down at the bottom here. No issue here. So we'll do that. I'm going to bring this back up, and we have our geometry here. World geometry. We have a couple other messy things going on here, so let me just tweak these. Set this to world lights, and there should be another thing here. Oh yeah, my camera. Nope, that's in the right spot. Great. Okay. So this is going to go here, and we're just going to do the same thing. Do /world /materials. On some of the 2D noise nodes, I found it hard to change the size. Like the first one, I think. How would you do that? Oh, okay. That's pretty interesting. C4D ate your heart out. Yeah, I mean, again, like I said, I'm from the C4D world, and I used it for quite a while. So, anyways, what we can do is we can come in here, we can change this color map and do the same thing we did before, right? We can just do op/objects Copernicus basics. Unfortunately, I called this Copernicus basics again. And then we can do outmograph texture. And now we have a quick surface material that has that. We just need to apply it, right? So what we need to do here is we can open up our materials and just drag and drop. And this will actually say, okay, do we want to put on the mesh, the ground, geometry, or world? This is our whole hierarchy. And I'm going to say, let's put it on the mesh, right? And so now we have our assigned material there. One thing we don't have is UVs on this, which is why we can't see this. So I'm just going to come inside of this and just put a UV project. This is on the ground, so we have some UVs, and we should be able to see this now, I think, if we come back down here. There we go. And so now we've got this crazy geometry going on here. We're able to bring this in. We've got our lights in here, and we should be able, if we play this, we should actually have that updating. Yep, there you go. So we actually have an updating texture. Now, obviously playing back a render is a little insane, but we have an updating texture on this, on the ground, that gets brought right into Copernicus. So, or into Solaris from Copernicus. So that's one of the things that Copernicus is really good with. It's able to make these textures that can then work kind of in real time. Making a normal map from that COPS texture for the ground would be super cool. I often do normal bump map stuff with COPS. Sure. Yeah, you could certainly do that. I want to go back to Mandy's question real quick, and I want to take a drink real fast. That went down the wrong pipe. Sorry. Have I played around? Well, at least there'll be footage of me dying if I die on stream. For content, like a true content creator, I have to capture all moments of life and death on stream. I'm totally kidding. Hopefully, no one would ever think that I'm any type of content creator. Please don't die on us. Well, I'll try not to, but I mean, it's gonna happen someday, right? I'm just learning how to drink water for the first time. It's a real new thing for me. Have I played around with solvers? Yes, I have played around with solvers. Not a ton, but definitely have. Yeah. All right, let's look at that noise texture again. This is really fun. This is just silly, by the way. It looks like he's on like a disco floor or something. But let's go back to our just basics thing that we were messing around with. The first one, I think, was the phaser noise, Mandy, was what you're talking about. And let's see here. So if we want to change this around, now the one nice thing about the composite view, I should say as well, is that you can actually change these values here. So like, if I'm looking at this, I can go through and look at different like outputs and things like that, not just the color. So like, if I'm over here, for example, I can change it to P, change it to N, can change all these things way easier than through these little drop downs here. So just something to keep in mind, that it is a little easier to see some of these things, especially if you're working with a bunch of different channels that you want to flip back and forth between. So changing the size here, well, the element size is going to be part of it, right? So that is usually what you would find here, right? If we wanted to change some of these things here, I'm not sure. I think this is the one that you were talking about that was hard to change the size of, maybe. Yeah, so there's usually a bunch of different things in here to like adjust different parts of it. Like this is the tiling of it. Okay. Most of them can't change the size from within the node. All right. Let's see. Well, there is no uniform noise. The fractal noise has an element size here. Interesting. I'm curious which one it would be. Now, the other thing that you could maybe be running into, Oh, maybe that's what it is. Maybe karma shading. That could be it. Maybe that's what you're thinking of, Mandy. Because yeah, those are tricky because you have to, if you're doing Material X nodes, you have to change the scale of your UVs. That's usually how. No, it's no problem. That's kind of the reason that this, like, part of the reason why this even exists now, because like this is so much easier to like mess with the scale of everything. And when you're working with noises in here and things like that, it should be a lot easier to work with. And what we do partially here, like for example, we have our geometry coming in here, right? With like, yeah, use a multiply after texture coordinate. Yeah, exactly. Yeah, you just tweak things in Material X there. What you can do here though, if you want to see things like, if you want to see like how your stuff is looking, for example, like if I wanted to see this right kind of in situ, like right, obviously we can't really tell from this texture what's going on here. What I could do, let me see here. I'm going to just move this around a little bit here just so we're not so constrained. It's the only bad thing is that Copernicus networks can get a little bit big. But if you're a Substance user, you can get some big networks too. I've seen professional presentations that are like, holy crap, those are some big networks. I couldn't even believe it. I actually saw one I was at a Substance thing at GDC, I want to say. And yeah, it was pretty intense. I mean, granted, it was for like Doom Eternal or some game or something like that. So it was like insane. But so what we can do in here is do preview material. And this is real, like it doesn't exactly sound like what it is. But what we can do is we can actually wire in our geometry in here, which is nice that we have our geometry available to us. And what you're going to see here is that I can actually, let me think here. Let me think. I should be able to overwrite this. I'm not sure if it will or not, but let's double check here. So if I do base color, okay. Yeah, unfortunately that's pulling that color in. What do we want to do here? Okay, what I'm going to do is just, since that has a color on it already, it's just kind of freaking us out a little here. So I'm just going to do a SOP geometry because this is a test geo. So I can just do this and just do a Cappy in here and have him do joint deform. So he won't have any color values on him in here. So I'm just making a new one basically, since it's something I have access to easily without the color attributes on it. So now I have this geometry and I can just wire that in there. And I should, what is going on here? Huh. Oh yeah, that's right. There is one in SOPs as well, isn't there? I forgot about that. Yeah, but where's this pulling its stuff from? Oh, here. Okay, got it. So we can just do a cop there. And then we could do... Huh. What are we doing? What am I doing here? That should have the lines in it, right? Oh, I don't have my materials on because it's actually adding a material to it. Ah, sorry, everybody. Brain fart. Maitland was just saying I have a recipe, so I don't have to set them up one by one. Oh, that's cool. Yeah, that's cool. Good idea. All right, so this should actually work in here now. Yep. Jeez. You gotta have your material on to see the material. That's just silly. Anyways, so this is kind of the idea for your preview material, and you could set these things all up and do it however, right? I mean, heck, I could even take this and throw this in here as like, I don't know, mission color maybe? I don't know if that would actually show anything here. Probably not. But I could use that as a base color, you know, put that on them. All right, now I've got this crazy animated pattern on here. So yeah, drawing within cops. Yeah, it's the, I think Philip's right. I think that you have to, so there's a little Cappy. It's coming in H22. Into my old Walmart pillow. There we go. Yes, he's a pillow. So yeah, yeah, the drawing, I don't think there is any drawing in here. Yeah, there's not like, yeah. So you would have to do a, yeah, like you said, you'd have to do a texture mask paint here with your geometry. So we could just grab some geo here. And this is where we can actually paint onto him. And then you would need to basically take this volume out from here and bring that over into Copernicus. But yes, it's yeah, it's definitely not super fast yet because this texture mask paint is its own thing, right? And so Copernicus is all GPU based, so I think there's like a translation that has to happen there. That's not super fast yet. But yeah, so what you would do here is I think you would grab this, and yeah, I'm sure you probably know this already, Mandy, but this will actually output a little null here, and you could just say texture paint, something like that. And I think you could import this as well. So like if you came over here, right, you could let's see, let's do SOP import. I'm sorry, I'm making this a bit of a mess, but you can bring this in and say texture paint. So we should have that there. And then I think we can do geometry to layer, maybe. Is that right? Yes, that is right. So this would then put that into its correct space, or into its, you know, into an actual layer in Copernicus, whereas this is like just a volume, like this is geometry. This is now a Copernicus layer, right? It's a float layer. And then you have this, and you want this to match it. So what we should be able to do is do a match camera from this, right? We could take this as the reference and this as the source. That should match it. Yep. So that's good. So now we have that matched in size, and you could like, I mean, this is just a mask, So we could do like a multiply here. We could just grab this and this, right? Something like that. And now we've got those shapes multiplied in there. We could output this to the base color, right? Like so. It would only go to those shapes. Actually, how would this work? Oh no. Oh, interesting. What just happened here? Okay. So yeah, what you could technically do here would be so let's see here. Let me just see if I can put that out. Oops. Put that to the color. Let's do that. So I'm just going to change this over here. Do out color. So that's our color out now. If I turn this off, it should be that. Yep. So we could do that. We could also do the preview, the cop's preview material. Throw that on here. Do the base color from the cop and say out color. And now I think this would work. So if I had this here, painted some more there and hit escape, now we'll have it like that. Now, this is the problem. You don't have the, you don't have this kind of back and forth very easily. But anyways, Touch Designer and Houdini in one program. Well, they used to be one program, so that's a very funny thing. They all used to be the same thing, and then they split apart. Anyways, so this is kind of cool. You know, you could see you could do some of this stuff here. I don't think that's cool. I forgot you could do that as well. Oh, that's kind of neat. So you could paint in 2D like this and actually see it show up. That's kind of fun. I mean, I can't tell where I'm painting, but it's kind of cool. That actually works really fast. Huh. Maybe I'm just doing it at a really low resolution. That's cool though. Yeah, funky Cappy. Funky animated mask Cappy, or animated texture Cappy. Okay, so we're screwing around with this stuff. Now that we've kind of seen some of what Copernicus does, let's get into some of the slap comp stuff and see what we can do there. So let's go into Solaris, and we've got our Cappy Bear here. We've got our crazy disco floor. You know what actually would be really fun? Sorry, before we go any further here, I'm gonna go into the emission. I'm just gonna copy this over because that would be really fun. And then turn this up. Yes, yes, please. And another thing that we should do here is we should set a geometry light for that ground. It's actually making the whole ground that color, but that's okay. We're going to go into here. We're going to go into ground mesh. Just make sure that that is selected. It's not pink though. That's the only. Maybe we. All right. We'll figure something out here. We'll figure something out to do. Okay. So let's do material tint glows light. And now we have our exposure values that we can mess with here. So we can shoot some light up at them. In fact, we could probably just turn off this Karma Physical Sky. Let's do the background as dark. There we go. And so this here actually will work now as the intensity for this emission. And I should actually probably change this to just 1 on the emission scale. Great. So that doesn't look like it's too insane. And we can do... So there we go. Now we've got like an exposure value here that we can shoot these lights up at him. And that should be making him glow from these lights, or from these shapes on the ground. What we could also do here, just trying to think. Oh, I don't know who came up with the capybara. I remember seeing it before it was launched, and I was like, that is like slightly creepy and weird. But yeah. Maybe also an idea to change P to UV and SOPs and paint on UV unwrapped space and rasterize that in cops. Yeah, that's an interesting idea as well, for sure. Oh, that's so cool. Thanks, Tom. I'm really, really appreciative of that comment. Sometimes it feels like you're just kind of talking and not really doing anything sometimes in these streams. For me, you know, just I've done a lot of them now. So sometimes it's just like hard to like remember that people are getting helped from these. So I appreciate that. Thank you so much. All right, so let's now look at the slap comp side of this, right? Because we have this slap comp network that we can use. We have our blur right now, right? And this is going to work anywhere that we're feeding this this value, or this basically this signal from Solaris, right? So we're using this so basically what we can do now is we can start to play around with some of these signals coming in from Karma, right? So Karma obviously has the ability to output different AOVs. So let's see what we can kind of mess around with here with our AOVs first. And then once we know maybe some of our AOVs that we can what we can kind of like see what we can mess with then in the actual slap comp side of things. Because right now we don't have really any AOV set up. So let's do that. Let's go into image output. And since we have this glowing on the ground, let's see if we can do that. Let's try combined emission. I have a feeling we're going to see that in the emission. Ah, shoot. So unfortunately with this, that is an unfortunate thing of the geometry light. The combined emission does not take into account geometry lights. I forgot about that. So I think let me think what we need to do here. I think we can do this though. Let's see if we do an extra render variable. Let's do combined emission. But instead of this, is it this? I can't remember. There's like something, it's like a really small change that needs to happen and it should pick it up. Let me see if visible lights does it too. Oops, I keep pressing the wrong thing. Oh. Well, it looks like visible lights does it. Well, there you go. Okay, cool. Visible lights. Beautiful. So what we can do now is we can actually take this visible lights and mess with it in here. So this is our current slap comp here, right? So as we go around here, we can see that obviously capybara is not going to be in here at all, right? This is not the part of our actual color setup here. And that's great. So now we should be good with this. So let's go back into our slap comp here. I am going to take this blur out because I don't really think that's going to do us too much good. Let's go to our slap comp import and let's just add the AOVs from the last render. You can see we now have visible lights in here. And let's see what we can do with that. So what we should be able to do, right? We could add something like a glow to this, right? From those. Now, the problem obviously would be is if we did this from our actual source, we would be getting, let's see here. Like if we did this and we did the glow threshold, right? Like let's say we wanted all of those things to glow. Well, Cappy's glowing too, right? Oh, that is funky. That's right, because we're in the camera perspective. Oh, that's so funny. Okay, camera one. No. Hello? What's going on here? Why are we in a weird space? Let me just turn that off for right now. Don't actually think we even really need that. Okay. That should work if we come back over here. Let me just double check to make sure. I'm just going to wire this glow in here. Let's turn our slap comp back on. Yep, there we go. So we're getting that glow. But obviously we're getting glow from Cappy. So that is where you would want to have something like this, where we take this in, right? And have some sort of warning generated. Let's move this down. So there, now we're having these just glow with the capybara, right? But the nice thing is this is actually going to go in front of it as well. So what we could do here is we could output the glow only, right? So this is only going to be our glow. And LPE tricks. I mean, gosh, I don't speak LPE tags very well, but yeah. I did a little video on them with some stuff, but I mean, believe me, I had a lot of help with that. I am not I'm not like an LPE whisperer or anything. So a question in the chat, Annie was asking, as a compositor, how would Copernicus compare to Nuke, After Effects, or DaVinci? It is really not it does compositing things. It is not a compositor yet. It is very basic. Yes. What it really is more comparable to right now is Substance Designer. That's what it's mainly comparative to. Nuke is such a big tool and such a well-developed tool. It would be like, I mean, it's the same thing as if Nuke wanted to have a node-based geometry system in it. How long would it take for it to catch up with Houdini? It's the same. We're kind of coming at things from different angles here. The one real difference is that Nuke is primarily a 2D compositor, as we're seeing here in these places where we kind of do some really funky stuff. Copernicus is technically a 3D compositor already. It already knows about 3D positioning because we're in the software. So there's some really cool stuff that we are coming at it from a different angle than Nuke, I think, inherently is coming at it from. So, I mean, Nuke has 3D stuff in it, right? But it's kind of added to the 2D side of things, whereas we have the 3D stuff and we're kind of adding in this 2D stuff to 3. Anyways, there's some interesting things I think that can happen there. And certainly if you've listened to some of the more recent keynotes, especially the 21 keynote, there's some really cool stuff in there that they start to give some ideas of what we see as the compositing benefits of Houdini, especially if you're compositing in like VFX into plates and things like that, or, you know, whatever. So, okay. So let's take this. We're going to take our color. We're going to blend this into the output. Oh, thanks. I really appreciate that, Maitland. That's very nice. I mean, yeah, that's the one thing I can maybe bring to the table. I'm not the technical expert on these things, but hopefully I can try to make things a little easier for the common everyday person to like try to understand a little bit, you know? So, okay, so here we go. We've got our stuff coming in here. Now this, I'm going to change this to RGB just to make sure that we're not, I don't really want to have any alpha on this. So I think that should work. Yeah, thanks so much, man. Thanks, Home Depot. Yeah, camera space, normal AOV is often helpful. Yeah, for slap comp, sure. So here now we have the ability to turn this glow on and off in this slap comp block. Now, this might be a little bit basic, right? And really there is something I should kind of mention here too, is that we do actually have these filter lists as well. So you can actually add all of these filters right in here. So if you wanted to add in a Kuhara filter, you wanted to add in a chromatic aberration, you want to add in the glow, right? Let's just kind of throw these around and see what we can do here. So let's do, hello? There we go. Glow, So this is going to be like almost identical to what it was that we're working with there. So we can do this glow threshold. Now this is not going to take into account the AOVs and things like that, but we can, I don't know if this Kuahara filter is going to do much of anything. Sorry, let me just see. No, that doesn't really do anything. It's a little too... All right, I'll just remove that, delete that filter. Let's do the glow. Let's do the chromatic aberration here. And anything else? Let's see. Let's do a vignette maybe. Yeah. So this is basically like a really bare bones slap comp thing, right? So this is actually in this same little setup. And we actually have, this is actually making a little, like if you look really closely here, this is actually making a cop network, but it's a very like controlled and self-contained cop network that is then doing the slap comp for you. And you can see here, we've got all the, all the things you'd kind of expect from here. And yeah, you can do all the chromatic aberration craziness and, go wild, do some wacky stuff, woo, anyways, so the if you're doing simple stuff like this, you don't have to worry about doing your like actually building a cop network for some of these things. If you're just doing that's what was missing from our cactus trip. Yeah. So you don't have to worry about building out these networks, right? Because it's working. Now, if you want that more fine-grained control, certainly that is where, like in this case, we have this glow here. Let me actually go back. Sorry. Edit the current filter list. Let me just have just the glow on here so we can kind of compare this. I'm not sure what my threshold was, but whatever. So there is our glow, right? We could just output the glow only, right? But it is, this is a little bit of just, this is the bare bones version. If you want to have more control with AOVs and things like that, that's where you go into the slap comp and you actually have control over those different parts of it, and you can get in there. Now, another thing I should mention as well is that I believe if we render this to mplay, just in this case, like we're rendering it to disk, like, doing an actual render, I don't think that this slap comp should show up by default, if I'm remembering correctly. Chromatic aberration and vignette, the holy grail. You can see I just installed this today. I usually install daily builds, so if something hasn't loaded yet, it's like, yells at you. So here is our render, right? But the stuff is not applied. If you want to apply things, there is actually a little area here for slap comp. And you can add a filter list here. We should be able to find that. If we go here, there's our cop filter list. Can hit accept. And we should be able to render this to mplay now, and hopefully it will show up with the filter. Fingers crossed. Yep, there we go. So there is our filter on there. If we wanted to render this with the cop network that we built, we could go in here and say slap comp, I think. I think. Let's try it. I don't know if, oh no, it's not happy about that. I think I need to do, yeah, it didn't like that. Sorry, what are we erroring for here? Unable to find the cop. Maybe the block end is what we need. That's probably what we need. Yeah, let's say that that's right. Yes, because this is block end. Yep. Okay. That's probably what the issue was. Let's render this to mplay now. Yeah, I'm not seeing any error there, and we should get the glow, hopefully. Interesting. Maybe. Yeah, that's worth trying. Maybe op link to cop. Yeah, let's give it a shot. Can't hurt. I have a feeling that's more for the texture side of it, but let's try it. No, that didn't work either. Huh. All right, let's hover over this. The path to the block end cop of a compile block cop. Yeah, that's what I'm doing. That is what I'm doing here, guys. That's weird. Well, I am not sure why that is the case, but that should be working. He says, confused. Strange. Very strange. Well, yet another reason why you might want to use the image filters, because it just is working. Yeah, I'm not sure about that. Well, I'm not going to be able to say what the answer is to that. Maybe the help card and the help stuff, help documents can give us a much better understanding of this, maybe. But I don't think so. Does it need a label? Okay, let's see here. So it looks like, just tried here, not getting anything either. Yeah, it looks like, okay, so I think there's a couple interesting things here. So I'm going to delete this, delete this, delete this, just to have see invisible lights here. And then I'm going to delete this, delete this. I'm going to crash Houdini real quick. Okay. Luckily I had it on autosave, so hopefully it saved that. Separate beauty pass for the slap comp to render. Yeah, maybe that might be right. Well, let's hope that autosave was on. Okay. Awesome. Well, that's totally fine. I'm sure someone else has done this just fine. All right. So I actually don't think that there's a depth coming out of this as well. So that's interesting. So let me delete this, delete that. I think I said that there's no depth, right? Okay. I'm just going to clean these all up. Because I don't think depth is being handled by default. Now I've just broke everything. Let's see here. Let me just go back, kick off a render again here, just so we have. Yeah, I might have to, but the other thing is that these. So I think what might be happening here is that this prim ID and instance ID are being done in here. So depth, visible lights. Yeah, that's actually a good call. I could just easily do all of that instead of like. What is happening here? Visible lights. Yeah, now I've broken everything. Now I've broken everything, guys. All right, there we go. I think that's working. That's working. Great. Yeah, let's add a depth in here. Where is it? Utility. Right? Depth. Okay, that should be right. Now we should hopefully have a depth. We have visible lights. We need. Is there an instance ID in here and all that stuff? There's a prim ID. Please tell me there's some sort of like, what is the other one? Instance ID. Oh, good. There's 2 prim IDs. Okay. Can I just do this? Okay. That's interesting. I mean, it doesn't really matter. I'm just going to do this and just call it instance ID and just call it a day. Let's see. Does that work? Just work. Bummer. Oh, I also remember all the outputs of the block have to be plugged into the block out. Oh, interesting. Huh. All right, here's what I'm going to do. I'm going to take these out of here. I'm just going to do this. And I'm going to say slab count block. There we go. We're going to add all the AOVs from the last render. We're going to grab the visible lights. We're going to add that to the color. Then output that at the end. And, Okay, here we go. All right, let's try that. Let's try it. All right. Last try. If this doesn't work, we'll just call it there. And you guys can go watch, you can go watch Roland Dolly's video. Dalvi, however you say his name, I can't remember. Dalvi, yeah. Yeah. I don't know what I'm doing wrong. I'm sure it's something really simple and dumb, but anyways, hopefully that gave you some thoughts about what you can do with slap comp and that type of thing. I mean, the other thing you can do is all sorts of, other, filters and things like that. Like if we did, like, yeah, here's another thing maybe we could do is we could take these. I'm gonna give myself a little more room here. Sorry. Do that. Put this up here. Let's give myself a little more room at this block end. And let's say we took those visible lights and we did like an edge detect on them. We could do something like that. And then just brighten them up a little bit. And then you could always, I don't know, like could maybe add these on top of that again. Make something kind of funky like that, right? Yeah, things could change. I don't know. But there, yeah, you can see now we've got this. Oh, I'm rendering an XPU and everything is being slow. Let's just do CPU so it doesn't have to compile the kernels. There we go. And yeah, you can see this is obviously going to work from any angle that you could possibly have it coming from. The other thing obviously you could do is you could, let's see here. What can we do? We could maybe... The other thing you could do too is you could pass values through a material using AOVs that way, like material AOVs. So for example, there, if we wanted to add something, let me just add a material library here. I'll just put this with the other materials down here because we've got an assigned material. So this I'm going to go inside of and make a Karma material builder. I'm just going to call this Cappy Mat. And we're going to throw this into this same world/materials. There we go. And then if I come down here to this assigned materials, I should be able to take this Cappy Mat, drop it on there, throw it onto I'll do it on the whole Cappy component. What? I am officially confused by that. Did I grab the wrong material? I must have. Yep, I did. Well, it just used that same material. That's really strange. Let's do Cappy material that way. There we go. Must have just grabbed the wrong one. Yeah, because now I've got two bindings. Great. Okay, so so I think Copernicus would be really useful for client work. So Enya is asking what's a real world time that this would be needed. I think a lot of times what Copernicus is really good for, because mainly what we're looking at here is like slap comp stuff. But if you were doing like building textures for geometry, there's lots of things that you can do with that within Copernicus. So let's just take a look at this real quick. Here, I'll just show you. I'm just gonna do like a noise of some type here. I don't know. Okay, so we've got some like funky shapes. Some shiny black. All right, let's do this P1. Then we'll just change the frequency of it maybe a little here. Get a little. So let's say we had this Karma Voronoi noise that we were using. We didn't want to use this actually for like a base color on this, but you wanted to use this as like an AOV somewhere else. Do a Karma AOV. You should be able to plug this in here. We'll just plug that in like so. What is this? This is a vector 2. So we're going to call this, let's do Voronoi, like such. And this should be an AOV that we get access to now within Karma. So now he's just a regular color, which is fine, but we should be able, oops. Whoa, what did I do here? Okay. We should be able to see we've got Voronoi now, and we've got this coming up. And so now if we went into our slap comp and updated this, we should have Voronoi in there as well. And we could do something crazy with this. I don't know. It's like a UV color, but maybe we could do UV to, let's do UV to mono. What? Or no, UV to, oh yeah, let's try that. Maybe I can. No, this is just going to do black and white, isn't it? Yeah. I was thinking like ID or something, but maybe this is better. I was thinking that would do it. Do like a random from that. Okay. Anyways, you could do this, and you could, again, we could just like add this on top of it or something. I don't know. I'm just coming up with nonsense now. But you can see that this is a value that's come through here. Sorry, we're looking just at that UV now. So I'm going to go back to the color. We can see here that this is something that doesn't even exist, right? In this value here. And you can see now we could bring in attributes from, from materials and stuff like that. So anyways, there's a little bit of the slap comp stuff, but let's go back over here to this Copernicus basics and see if we can't talk a little bit more about how that might work. So let's say we had, we grabbed, oops. I want to learn more of COPS and understand it more. Where should I go? There's probably some good training you could find through the side effects page, I think. And there's certainly some cool stuff that you can check out in the content library. So if you're looking for content stuff, go to that. It's kind of all now with the learning like platform. You can get to it all there. So there's some really interesting stuff there that you can poke around and play with. There should be some training stuff on sideeffects.com with Copernicus. I know we're trying to get more and more. This is a big area of development and it's still sort of in beta. It's like a well featured beta at this point. Whereas like, I think in future versions, it'll be fully like, this is pretty well sorted out. So yeah, here we have a few of these grunge things here. So let's use this Rust grunge map. You can see here, this is like a procedural, value or whatever. And let's do a SOP geometry here. Sorry, I'm making a total mess of these networks, but that's okay. Let's do a test geometry. Let's just grab the shader ball. That's easy enough to use. And let's do the preview material. So we've got our geometry there. And let's say we wanted to use this for, I don't know, metalness or something like that. Well, there you go. You can start to build up these textures and things like that, right? Let's see. Oh, I'm actually was thinking you could maybe do some curvature stuff here, but there's new terminology and parameters in COPS nodes that I don't know what it does. Yeah, that's a good point. Well, you can always ask questions too. Yeah, it's not too bad actually. One of the last times I streamed this, I was like poking around at it, like I don't know what I'm doing. But now that I've like started to get some of like the lingo and stuff down, like some of the node names, it gets a little bit easier. Also, there's not like a ton of nodes in here, honestly, compared to like other contexts. So, yeah, I think you can get at some of these things pretty quickly. What would I need for the curvature? It wants a mono source. Would this be like a depth map? That I'm not sure about. Computes the curvature. I'd have to think about that, how you would do that. You'd probably have to like you'd have to probably like rasterize the geometry or something like that. Or maybe you would calculate the curvature on it and then rasterize it to the UVs. Yeah, that might be the better way of doing it. But anyways, you can do all sorts of things here with this where you're starting to build textures and have masks based on different attributes and things like that from the 3D geometry and bring it in. Could I try a solver and just show what that's like? Sure, why not? Let's do that real quick. Let's just do another geometry here so we're not... We'll say Copernicus solver. Okay, so let's do a Copernicus node. All right, it's always a COP network. I always try to type Copernicus because I'm like, my brain's like, it's Copernicus. And let's see, let's do the flow. I think flow is pretty fun. So let's do this. So if we wanted to mess with this, let's do a, oh, you know what? Can we fetch in here? Yeah, we can fetch. Let me grab my fun little basics MoGraph texture. Let's grab that. Hooray. All right, we'll put that into the color channel. Then we also need, what is this yelling at me about, just so I know? I think it wants at least the color and the velocity. No, it doesn't even need that. Look at that. How fancy. So obviously we only get the initial start value of this. So this is already starting to solve. So that's really good. Let's see. Let's do some sort of noise here. Let's try that phaser noise again. And we can maybe have this be our velocity. So we're gonna do this in UV space because that's what it's looking for here. Let's make the element size way bigger. Maybe something like so. This could be our V attribute. There we go. We're starting to get some solving happening here, but obviously that's not super interesting. And if we do, let's see here, 3D noise and do some animation of this. Oh, that's really slow. Wow. Oh, interesting. It doesn't change all that much. Okay, maybe this is a bad one for that. All right, let's do this. And let's see if we can say... Okay, let's do that. Let's do this. Let's animate that. And now we're going to have these crazy slopey things happening because we have a 2D noise here. I'm curious, actually, could we do this in UV? What would this do? Technically, either would work, I guess. Let's try that, actually. Let's just throw that in there. See what that looks like. And in fact, as I'm thinking of this, it's probably not going to be animating. So it's just keeping the same value. So I think what we would actually want to do here is pull this inside and do an add to the velocity, like so, just like in a solver. We kind of want this to be happening inside of the block. So let's try this, see what this does. Yes, that is true. It's going to do that. Maybe blending the two together would be good. Or honestly, maybe it doesn't even have to add. Maybe just we do the results in like this. Just cut this out here. Just have it inside of the solver. Yeah, so this is sort of doing some stuff, but let's try this instead. Let's try to do the mono. Let's plug this in here. I'm probably gonna break something by doing this, but yeah, so we can do some stuff like that. I mean, there's all sorts of different stuff that you can do with it and, you know, push things around and all that kind of stuff. Let's go back to this. Let's get rid of this. And I wonder if maybe if I should have it centered around 0. There we go. That's what I was missing. Okay. Now we're getting somewhere a little bit more interesting. Yeah, there we go. So yeah, so this is solving. One really interesting thing that you'll see that's a little different about this is that it doesn't actually cache the whole thing because it's actually pretty quick to solve, especially in a 2D flow solver. So like if I hit stop here and go back, it actually solves like all the way through it. Like it like goes from one of these checkpoints and solves forwards. So it's got these checkpoints built into it. So it's actually pretty fast to just like scrub around in it and things like that compared to what normal solvers would be. So yeah, so you can do all sorts of interesting kinds of wacky stuff here, I guess. In fact, I wonder if was it slope here? Let's go back and do that one more time, because maybe that was my problem. That's pretty trippy. I don't know. Anyways, I think that's pretty fun. So I think part of the idea here is, now that's Touch Designer. I think the idea here is that you want the center to be close to around 0. And then, yeah, you can start to play with some fun stuff. And you could always inject more like color to this, right? Like you could do this, and then you could take, like you might also want to like maybe pass this. Oh, right. That's a, oops. That is a cable. So if we do a cable pack here, throw this in, should be able to pass that through like so, because this wants to be a cable. And then if we do a, I mean, this is just one, so you could do a cable unpack here. And this will feed through that color the whole time. This will actually feed through the animated thing. And what you could do then is you could screen this on top of it, I think. So we can do color. That in the loop. That should start to do some stuff. Was I thinking that screen wouldn't be like, is it overlay? Is that what I want? That's what I want. Yeah, that's what I want. Overlay. So you can do stuff like that, you know, where you're kind of making these crazy blendy things. And yeah, by kind of getting somewhere in the middle there, you could kind of mess with the blend mode of it and stuff like that. So yeah, you can almost get like a weird, like, it's like almost like Lord of the Rings-y kind of thing happening there. And if we bring the element size way down here, we should start to get some more like wacky details of this, right? Super, super weird. I don't know. It's a thing. Ooh, jittery, very jittery. Yeah. Lots of options. Anyways, so that's kind of how some of the solver stuff works. You can also do temperature in there and have like buoyancy and stuff like that. So I think if we threw in like SDF shape and did like if we did an SDF2 mono, threw that into the temperature here, I think that's going to do some stuff. I think. Maybe not. Actually, let's let me just do this, actually. There it is. Okay. Let's all calm down here, folks. There we go. Now we're doing some solvers. So here's what the temperature is supposed to do. It's supposed to actually work like it's like a quasi-fluid solver type situation. And you can see that it's actually wrapping back around. I think if we go up here, we can actually say default border is clamp, maybe? No, constant. Huh. Oh yeah, okay. It just didn't start up back again. Okay, that's what you'd want, whereas like more of like a constant like that. Yeah, so now we've got that actually like rising up basically. Oops. And so we could actually translate this down. And there you go. And then I think you could kind of add this. Let's do this. Let's add this in here with this. But we're going to do just a tiny little bit of that noise. Just an eensy-weensy bit. There we go. And you could maybe just do like... a screen would be better maybe, or maybe like an overlay or something again on this. Yeah, so there we go. Got some fun stuff going. Hopefully that's gives some ideas of what you can do with solvers in Houdini. Yeah, so I think that's where we're gonna end it today. Wow, this is quite a long stream. But that's what we get for just kind of going blindly into a fun thing like Copernicus. But yeah, hopefully you learned something here. Hopefully you got some information out of it. Yeah, there's lots that you can do in here. There's pyro stuff. I mean, you can bring these attributes back over and drive other simulations, things like that. So yeah, hope it was a fun little walk through some of what you can do over in Copernicus. I'll throw these files up online. You can, you know, again, if you go to HoudiniHangout.com, you can get a link to the Discord server. There is a HHHip files channel, which has a, what do you call it? A Google Drive link to all of the files that you can grab. And yeah, should be something you can poke around at and do your own stuff and play around, see if you can fix any issues that I ran into. But yeah, thank you all for watching. I appreciate it. I know some of you are up super late, so hopefully you got something interesting, and we'll hopefully be able to do something cool next time. So if you have more topic suggestions, things like that, throw them into the Discord server as well. And other than that, I will say that we're going to be good for this week, and hopefully get to chat with you all same time next week. Keep an eye on Discord and stuff like that for any stream announcements. And yeah, I'll talk to you all next time. Thanks again for chatting and for all the good comments. And yeah, talk to you soon. Have a good day, night, whatever time of day it is for you. And we'll see you next week. Bye, everybody.